All right, I think we are live. I'm just gonna wait to see that the live stream starts on my end, which it looks like it has. If someone can confirm they can hear me, just to make sure things. There we go. Jake says good morning. Good morning, Jake. How's it going? Yeah, welcome to live stream number 8, porting the source code for the J programming language from C to C++. Awesome. Jake says that you can hear me. And I think I've finally fixed the latency. So let me know if there's like live stream quality degradation in terms of like 720p or whatever. Because I think I now have the latency reduced from like whatever it was before, 10 or 20 seconds down to a couple seconds. And there's actually like an ultra low latency. But we'll try this out today. Jake says, not too bad today, just logging into the work systems. Yeah, I just mostly finished my work day. I might do a tiny bit of work after this live stream. So yeah, we'll probably live stream for an hour or two. I don't actually know what we're going to work on today, but I figured I don't think I've done a stream in roughly a week. So yeah, first things first, let's highlight, so no open PRs. I've merged all of them, all of the open ones. So yeah, thanks once again. We had a new contributor, Herwin, who contributed a bunch of PRs, and then Juho also contributed a bunch of PRs. Nathan contributed one that actually fixed our table generation options. Hey Robert, how's it going? Yeah, and feel free to say hi in the chat. If you're a recurring member, I'll just say hi back. If you're a new member, feel free to let us know where you're tuning in from, and I can shout that out. But yeah, so lots of PRs went in, I think, and so yeah, this was the tail end of our unit test work that ultimately didn't end up working, but if we can navigate our way to, where was it? It was in the J library, right? CD, I feel it was in system main. That's not going to work. Where did we put unit tests? We put it in a new file, didn't we? Yeah, util. And then we put it in P as a joke because K got renamed to Q, so we figured J would get renamed to P, at least for our word functions. And who pointed it out? We need to shout this person out. I think it was immediately afterwards. Remove. Where is the UT? There might have been an issue that was closed that immediately got unit test. Is this the issue? Oh yeah, so it was Herman. Or no, was it Herman? No, it was Juho that pointed out. So yes, thank you very much, Juho. The issue that we were running in, for those that are either watching now or watching later, was that in verbs, aka functions in J, X and Y are used as the argument names. They're hard-coded to be the argument names. And we found that invoking a script that had a local variable called X or Y from a function ended up with a name collision, which a ton of the unit tests were doing. And at the end of live stream number 7, I sort of gave up. But then Juho posted that there's this neat little erase that you basically can say delete this variable name or argument name, and in this case, the collisions disappear. So hip hip hooray for that. I think I ended up merging this and calling it UT. Did we just see that? Yeah. So that now what we can do, if we go back to our JSource, type in console. Now if I want to run, G100, I just have to type UT and then in single quotes the name of the unit test, which is a lot nicer than, if you recall, previously what we were doing was this ugly one-liner. So it's actually two separate statements separated by the same verb with, like, I don't know if these are form functions or what they are, but first you have to load tsu.ijs, and then you have to load the name of the script. Now you can just call the UT in single quotes, which is what I wanted. So yes, like I said, thank you to Juho for pointing that out. And yeah, other things that are worth highlighting that were pretty big PRs that went in. We've Clang formatted the whole code base. Clang format the code base. I was sort of torn about merging this. But I decided to merge it. I sort of liked the porting individual verbs one by one and then getting the satisfaction of the initial Clang format. But I'm not one to say to basically close PRs. Unless if the PR you open is completely antithetical to what we're working on here, I will either leave comments for a few small changes, or if there's needed to be large changes. But this is just refactoring, so usually it's been pretty minimal, the things I've asked for, or it just immediately gets merged. And if we go to our JSource main page, Clang format is one of our primary goals, so it would be a bit hypocritical for me to put this on the list and then close the PR. Bracket code bracket asks, J is an array programming language. What do they mean by that? Well, sure. Let's do a little demo here. So let's actually clear this and make it with a nice, pretty background. So yeah, once again, if we type console, say you have, so arrays are first-class citizens in APL or in J or APL or any other array programming language. So when you type 1, 2, 3, you get 1, 2, 3, and you can take this and then add 1.123 to it, and you're going to get element-wise addition here. So in most programming languages, you can't do this. In Python or in Haskell or Java, C++, you name your sort of imperative programming language, you'd need to either set up a for loop or use a transform or map algorithm in order to do this. That's sort of like the basics, but you can do a ton of other things. So I believe this is iota 10, gives you the numbers from 0 to 9. And then this sort of little unibrow guy, unibrow character here is reverse, or it's not reverse. It is, I thought it was reverse. Right, I always get this wrong. It reverses with the single. Yeah, so reverses with the period. And then sort of the classic thing that I always show is you can do a multiplication table very easily by doing the following. So that's a multiply. Is that actually, I feel like that is right. Yeah. So this is the same thing as doing, so this little squiggly here just means provide the same argument for the left and the right argument. And this is basically outer product, which means for every pair of elements perform a binary operation, which in this case is multiplication. And if we were to change this multiplies to plus, you get addition table. So the most popular array programming language you've probably heard of is Julia. I'm not sure if actually R qualifies as an array programming language, but R is also pretty popular. And if you're a Python developer, um, there is a library called NumPy, which is, I think, the most popular, the most downloaded Python library. And this is basically a domain-specific language in the form of a library for array programming. So you can do a lot of these things the exact same way that we saw. And also, while we're talking about it, some pretty exciting news is coming out of the Elixir community. Elixir, for those of you that don't know, is it's a basically modern version of Erlang, which is a very fault tolerant, distributed language. It was used for telecom. It's used by other famous companies like WhatsApp. And Elixir basically takes the Erlang model, adds Ruby syntax, and then steals a bunch of other cool ideas from Clojure, I think is their primary language, other than Ruby and Erlang. So it's basically Ruby syntax plus Erlang plus some other things. And they've just announced NX, which stands for Numerical Elixir. And yeah, if you're interested in array programming languages and sort of numerical computing, I highly encourage you to go listen to this podcast it's with Jose Valim. It's called, what is the podcast called? Thinking Elixir. It's like an hour and 20 minutes. I just listened to it yesterday, the day before, and it's extremely, I found it extremely interesting. They reference Google JAX and TensorFlow XLA as their two like North Stars, and they're talking about how basically they're designing it such that they have basically kernel fusion, which is an academic area that I'm very interested in. I recently learned that ArrayFire, which is a very popular sort of linear algebra library for sort of array programming domain, once again, where does it have? I guess I have to ArrayFire overview. It also does, if I zoom in on this, JIT. ArrayFire performs runtime analysis of your code to increase arithmetic intensity and memory throughput while avoiding unnecessary temporary allocations. It has an awesome internal JIT compiler to make optimizations for you. So basically it takes your code, and if it can, it identifies opportunities to like generate a single kernel instead of multiple kernels that are then used on the GPU. Anyways, I'm not an expert in this area, but in a decade I will be. And it's very interesting that Elixir is basically targeting sort of the NumPy ecosystem. And that's also what I do for my day job. I work on a GPU accelerated library called Rapids QDF, which is basically a GPU version of Pandas, which is the second most popular Python library. Anyways, very, very interesting for those that are interested in this space, because, this is just another version of a long list of libraries and languages that have been influenced by APLNJ at the end of the day. And also, speaking of podcasts, the most recent guest on Lex Friedman's podcast was Keller, I believe. Yeah, Jim Keller. And I can highly recommend this as well. There's a lot of interesting talk about sort of GPU computing versus what he's calling like graph computing. I don't fully understand it. Where does he talk about it? Chris Latner, how GPUs work, Software 2.0. Yeah, I guess he doesn't actually specifically refer to it, but it's like it's hardware, deep learning specific hardware, and the trade-offs between like GPU compute versus like deep learning targeted compute. Anyways, very interesting. Hey, Joao. Yeah, Joao, you would be very interested in everything I've just been talking about. You were the one that linked me to what was the Google language again? I'm not even going to remember it off the top of my head. You will tell me in a second. And then Jake, I mentioned one thing I've never seen array languages used for is string processing. Would be an interesting thing to do. So yeah, I mean that's like a GPU myth. I mean stood strings like in C++, yeah, they don't work well on the GPU, but Rapids cuDF. Let's go to the docs. The docs. I mean, we have a ton of string support. In fact, I don't do a ton of programming. Like I work on, the term that, the marketing folks use is AI infrastructure. But literally what that means is I work on the back end to the Python API. So I work on the C++ side of things. So I don't spend a ton of time writing Python code for string stuff. But like some of the most of the examples that I have coded up in the Python API has been working with strings. There's a ton of like n-grams and bigrams stuff that's used for like sentiment analysis. So yeah, it's like a myth. We have a ton of APIs that are that take strings as in their interfaces. And it's just like behind the scenes, it's just basically creating a string of vector or a vector of characters with offsets to identify like where the strings end. And you just went from dealing with strings to dealing with vectors, and GPUs eat vectors for breakfast. Whether that's a character literal versus an integer doesn't make a difference. So it's a little bit more work to get strings on the GPU, but like this idea that strings don't work on the GPU, it's a myth. It's just that it takes a little bit more work. And yeah, Joao's saying is Dex is the language. Yeah, I looked into Dex, and yeah, it's still on my list of languages to look into, but Dex. The thing about Dex is that they're basically trying to keep the for loops. Where's the paper? Dex language. Is this the paper? Yeah. So I read through this paper, but like the thing that they're trying to do is they're trying to keep the for loop, which is kind of like, I don't know if that qualifies this as array programming. Like it's like array programming asterisk in my opinion, because the whole idea of array programming is you operate on arrays. You don't operate on single elements at a time. That being said, I haven't looked into this enough. It's definitely still interesting, but anyways, a lot of interesting stuff. XLA and JAX, I mean, that's not new, but the fact that Elixir is using it to build up NX. Code asks, am I still working at NVIDIA? No. Yeah, I work, or yes. The answer to that question is yes. I work at NVIDIA still. Joao said, are GPUs more general purpose than TPUs? I believe so. Like TPUs it's just Google's hardware that's specifically built to specialize for TensorFlow, is my understanding. But I'm not a hardware specialist. I'm a software specialist, so I could be wrong about that. Jake says, I work on SIEM solution, so I write a lot of string processing code day to day, which stands for Security Information and Event Management. Robert says, the example looks like Python from Dex. Yeah, it looks a little bit like Python, like a generator expression kind of thing. And Joao's pointing out that you sort of still are working at the array level here, just giving you the ability to index with sort of more familiar notation. I guess that's true. But yeah, I still have to look into this more. Anyways, we're on a huge tangent here. Why did this all start coming up? Because, oh yeah, someone asked what is array programming. I ended up mentioning NumPy, which then led me to mentioning the Elixir project NX. And yeah, that's going to be very interesting. Anyways, we'll hop back to this. So yeah, we Clang formatted the code base, which means that now if we go into our JSource and we cat, we were at like 48,000 lines of code. Now we're up to 82,000 lines of code, which is actually less than I thought it would be. I thought it would at least double. So interesting that, you know, but the point is we're back up to like where we started. So we'll see where we end up at the end of the day. And then also, yeah, Nathan submitted a PR that added the ability to use a nicer syntax in our restructured markdown text, or restructured text. The problem is something I've learned about Sphinx now, which I can't actually believe. Sphinx tables. I can't believe this is the case. I'm not sure which one of these shows the tables. This one does not. This one does not. This one actually doesn't look. Yeah, this is what I'm looking for. So where's the tables? Lists, tables. So yeah, if you notice, every single one of these tables has a blank line underneath the column header. And that irritates me to no end. It looks really bad. So even though now we have a nicer syntax thanks to Nathan, where we don't have to actually manually align everything by hand, I don't think I'm going to use any tables if this is how they're going to look. So sad face on that. If anyone has a solution on how to get tables that don't have empty blank lines, feel free to open a PR or an issue letting me know how. All right, so yeah, the last thing we want to do is just highlight. Sometimes I forget to do this. We go to contributors. Oh yeah, and I guess it's going to be interesting now because we just did all the Clang format stuff. So Herman, perennially in the lead for deletions due to the fact that they deleted OpenSSL, which was like 97,000 lines of code. But once again, just thank you to everyone that's been contributing. Herwin is a newer contributor that was doing some stuff with the base 64 directory. And I guess, yeah, now Juho is in the lead for additions because they Clang formatted our codebase. So I am no longer in the lead for. I guess Robert even was in the lead before. Not that it's a contest, but anyways, just super awesome that folks have been contributing, and it's been making this go a lot faster. So the question is, what should we do today? The first thing, actually, which is a very simple PR that we can do, is we can just go. I left an example in, so actually let's build the docs. While this is happening, I submitted a PR. Was it yesterday or 2 days ago? Where I deleted like 1,000 lines of code by identifying functions that, for some reason, the compiler can't identify functions that are not used if they're externed. So if you're ever looking to delete code, if you can go and find functions that are only called twice, once, or only mentioned twice, once in the extern and once in the definition, those can all be deleted. So there was, I don't know how many, it was like 20 or 25 functions that I was able to delete just because they were never getting used, which was awesome. And so let's open Opera. And so yeah, you can see that there's this section tables here, which sure enough has the empty line which I mentioned. So we can delete this because this was just sort of a demo as a part of Nathan's PR. So let's go do that. CD should be in docs. And then it should be in source. All right, so actually, I guess we're going, and we're just going to go open this, and then it's in index. It's in one of the RST files. So not this one. Was it in? Yeah, it's here. So we can get rid of this. But so this is, it's super nice in that previously, in order to get this to line up, you would have to like go through and do this. And I don't have time for that. And in fact, the fact that like a markdown exists like that, I guess it gives you more flexibility in how you structure your tables, but I'm sort of surprised that there's not a nicer way to do that. Anyways, now we can just do this and it'll work. But like I said, you get this empty line here, which is silly and I don't like it. So odds are, even though we have this, I'm probably not going to use it much. So we're deleting that, and we need to go over to dev, merge main, fast forward, and then we want to actually, and so Robert mentions, are the docs hosted somewhere, or do you have to build them to look at them? You have to build them currently to look at them, but I guess we should set up an issue for that. My long-term goal, or short-term goal is new issue. Although this is something that like I have to do, nobody else can do, I think, is to set up GitHub pages and link to docs. Joao, when you're saying things should render org mode, I don't understand. Is that sounds like an Emacs thing or something like that? What is org mode? Sphinx documentation. So this is, documentation. And so ideally, not ideally, end goal when you go to the, GitHub code, or what it'll be, code report, .github.jsource.io or something. And if I want in the future, I actually have like 3 or 4 domains that I have that I currently am not using. So I could link one of them to them. Org mode is an Emacs thing. Awesome markdown format. Oh, okay, yeah. So I was, that was sort of a shot in the dark. But yeah, I've heard of org mode, but I am not an Emacs user. And unfortunately, I'm not about to become an Emacs user. I've heard of the productivity gains, but due to the fact that I have a YouTube channel and stuff, I think it's in my best interest to be using what most students and new developers are using, which is VS Code. So yes, submit new issue. So should we submit this as a PR? Sure, why not? Git commit, and go to JSource now. It should ask us about this. I guess it's the doc thing. All right, so this is running. While this is running, we have to decide what we want to do today. So our options are we can delete some code, or we can port some verbs, or a verb. Jake says the university here actually has all students using JetBrains Suite for all of their subjects that need coding. Interesting. Yeah, I mean, I've heard fantastic things about JetBrains. Actually, speaking of JetBrains, should we go to Twitter? Am I logged into Twitter? I'm not logged into Twitter here, am I? Let's just go look for the Sea Lion announcement. I spelled that wrong, but is this today? December. I don't want December. I want maybe I should log into Twitter. Maybe it's not. Is it Sea Lion? Yeah, screw it. Let's yeah, see, the thing is, I think it's gonna mess up my if I log in. Actually, let's just go log in. Bring it over here for a sec. Log in. All right, let's find. I want to go to Phil Nash, who works at JetBrains. This is might possibly be the most amazing thing I've seen come out of a C++ IDE. And apparently it's been in ReSharper for a while. It has code completion on free functions, basically, which is absolutely phenomenal. So, like, you know, typically in languages that don't prioritize generic programming, you know, not that Python doesn't prioritize generic programming, but, you know, you've got your Python, you know, counter or dictionary, and you go dot, and then you can get a list of all the things. Well, in C++, because we have generic algorithms that work across different containers, and they use the iterator abstraction, you don't get this code completion because it's a free function. It's not a member method on a class. It's just a free function. However, at least to some extent now, apparently Sea Lion and ReSharper can do this. So it shows you that FL is basically being passed in as an argument. And if you just go FL dot, it will find you free functions that take FL as an argument, which, that is awesome. I don't use Sea Lion. I actually have a free year license that I have not started using. But like, just seeing this makes me like salivate. This is fantastic work on, and if the fact that it's been in ReSharper and that I didn't know about this, and that's the thing is, like, Phil is pointing out here that this basically makes up for the lack of uniform call syntax, which was proposed to get into C++, but died in a fiery flame of death. And D programming language famously has UFCS. And it enables you to use free functions as if they were member methods syntactically. Anyways, what are the chats saying? Wow, that's powerful. And Joao, your link did not appear. But if you want, as I've mentioned a couple times, if you want to, we can merge this. In the discussion tab, you can link it. Try J. Oh, neat. Damn. Look at that. So Nathan, the same individual that did the restructured text markdown. I used to work with Nathan, actually, in my very first job here in Toronto. Has set up a cool sort of try APL thing. It's not a REPL exactly, but yeah, this is similar to REPL.it is what he mentioned. Or there's like 1,000 of these now, JDoodle tutorial something. So that's really cool. How do I give this this is there, can I give it a heart? There we go. This is awesome. And we should add a link to this in the docs. Let's go do that right now. So let's remember, oh yeah, so we'll remember, what was I trying to do? Just highlight that you can post links because YouTube chat typically eats hyperlinks. So if you want to share a link, feel free to go here. So let us go to I did not mute myself for that. Whoops, I apologize. Bless me. Try J. If you would like to try J without building, thank you, Joel. Without building from source, check out this site. Look at that. Commit changes. Oh, and so this was the line, the link that you were trying to share. And sorry, so you were saying, so let's close that. Flax has tables without the extra line. So yeah, my issue with this again. So I'm not sure if Flax is usable in this Sphinx project, but if it is, does it need to be aligned? GitHub Markdown does not. Restructured text does. Flax is a library. Interesting. Well, maybe in the future we'll look in to see if we can hook this in. I should ask. I missed Joao. So yeah, I missed a couple messages earlier. I should ask JetBrains for an APL IDE. Probably due to the fact that APL is proprietarily developed by Dialog. They're not going to make one. But Dialog already does have an IDE. Allosace? I apologize for mispronouncing that username. Do you like the ranges name for the ranges library? No. But that's okay. I mean, ranges was named ranges long before I ever started looking into range algorithms. The only reason I don't like it is because iota is primarily named range in most programming languages, and I think we should have renamed iota to range, um, and that would have necessitated not calling the library ranges, because then you'd end up saying thing in the in the C++20 ranges library, the range algorithm, and that's just one too many ranges. Flax is a Python library for deep learning based on JAX. Oh, interesting. I see. I'm totally confused then. Flax is not Markdown. It's a deep learning library. Interesting. So I'll put this on my list of things to look at on top of NX, JAX, and now Flax. And what was the other one? XLA. Yeah. All right, let's get to. We're already 40 minutes in, so we're almost halfway through our stream. We've merged a couple things. Stood : ranges : view : range. Totally looks great. Don't know what you mean. Well, I mean, you don't need the ranges technically. It would be stood views range, because you can omit the ranges, which I'm not sure for convenience. But still, the way people colloquially refer to it would involve two ranges. All right, so I just want to port some stuff. How Ravel is like 100 lines. More than 100. Oh, no, yeah, it's roughly 100 lines. So maybe not. I feel like we have to save iota. Interesting. Jake says that they get compilers if they use stood views. So I always explicitly state it. Interesting. I've not run into that, but I've only been using GCC 10.2, so my guess is, yeah, I'm sure there's some compilers that you run into issues. What is IRS? So take and drop. You'd think that take and drop would be pretty simple to port. Oh, this is take R and drop R. So what are they doing? They're declaring two local arrays. And this is return 0. So they're basically ensuring that, or they're creating a scalar from the integer n that's passed in, the int64. And then what is IRS2? IRS2. All right, we need to go JSource. IRS2 common. Non-negative rank. What does IRS stand for? It's the new version of tax office for J programmers. Use IRS 12 to call a verb that supports IRS. All right, let's take guesses. Internal Revenue Service, I think not. My guess is the R stands for rank. The I stands for integer. Integer rank scalar. Integer rank scalar. That sounds like a decent guess. What if I do this? What if I do that and then rank 20 results? Intermediate rank supply? Integral rank support. All right, well, we know what it stands for now. Integral rank support. Of course, it only... So this, once again, is the little bit arithmetic trick where they give things, you know, single pop counts, and then they do bitwise ands and bitwise ors to treat them like predicates. Jake saying nothing like starting your work day by needing to rebuild GCC from source. That sucks. But my guess is that if you're building it from source, it's because you're living at Edge and you're on like C++ 20, which is nice. I mean, I'd be surprised if you're having to rebuild like a C++ 14 or 17 compiler. Integral rank support. Maybe we should Google it. Although the question is does it really is it really necessary to understand this right now? J software. All right, Roger Huey, the main implementer of the J programming language. Rank is elucidated through an executable model. Integrated rank support for specific functions can be vastly more efficient than the general algorithm in computing V double quote R. And uniform verbs provide a way to extend the more efficient implementation to a large class of verbs. Jake says that they're on C++ 11 building GCC 10.2 from source because we still support RHEL 6 and Ubuntu 14. Ooh, next release, C++ 17. That'll be nice. So this is just an optimization. I will read this paper later and make an executive decision because I don't think it is the best use of streamed airtime to be reading papers. But okay, so what we know is that IRS stands for integral or integrated rank support, and it is just an optimization for certain verbs. Okay, so let's go back to v.c. And interesting, so this is calling JT drop, so where is that? My guess is this function is way more complicated than the R one, because this is just a wrapper. That's not it. JT drop. Found it. How many lines of code is this? 80? How is drop 80 lines of code? That's insane. So drop, for just so that we're all on the same page here, say we have iota 20, and then I go 10 drop iota 20, it drops the first 10. And I think, if I recall, yeah, so in the standard library, they do have a number of already wordified functions. And drop is one of them. I recall seeing that in the stdlib. So it's a relatively straightforward, I mean, and so on a multi-dimensional, so if we go iota 1010, and I go, so actually here we want to take, so actually what happens, yeah, if we go 3-3 drop, that should leave us with like what, 7x7? And it's going to be like the bottom 7x7. Yeah, I mean, should we just start trying to port it? I want to do take first though. Is take right above it? Let's do it. Let's see how far we can get in an hour and 8 minutes. Bob, hey Bob, how's it going? Wordified verbs aren't able to make use of special code combinations. I'm not sure what a special code combination is. Is that, I assume that doesn't mean just like basic composition. It refers to some kind of shortcut or something like that. But yeah, let's just go for it, you know? We're not going to get very far. But let's do it. And this is a dyadic, so it's our first dyadic verb that we're going to be porting. So this is going to be take dot cpp. Actually, what am I doing? We have to save this and then go take dot cpp. And we don't even have a monadic directory yet, so we need to create dyadic, and we want to call this take.cpp, and then we want to go to and steal this. Bob mentions that some combinations run orders of magnitude faster. I see. So is this what are like the equivalent of idiom optimizations in APL, where if it's able to recognize some sort of idiom, it has custom code for that? And so you're saying when you use the wordified J, it precludes you from taking advantage of those idiom optimizations? That's my guess. So 100 lines of code. That's a lot. Let's see if we need to add this though first to our CMake file. And add this, we should go afterwards, verbs, dyadic. Okay, yeah, so Bob's confirming that sounds like the same thing, yeah, idiom recognition, which is just, yeah, it's just special code that is recognized by the J parser or APL parser. And so if you use the wordified versions, you're, yeah, omitting those optimizations from happening, which is good to know. So let us, we're doing take.cpp, let's go see if this builds. And also, we want to turn the dock building off. All right, well, this did not compile, but not to any changes we made, other than the fact that this is now a C++ file. Invalid conversion. This is on line 69, or 25, line 25. Interesting. Chris. What's up, man? Chris is another individual I used to work with. A creature of beauty. So, it's upset. Not that this is recursive. Have a good one, buddy. Enjoy the office hours. So invalid conversion from 80 star, aka asterisk JAA. So what is the fix for this? So this is a macro, rank 2x. Oh yeah. To AF. Well, I have no idea if this will work. That did seem to work. I think. And now it's complaining about a different issue on line 40. It's saying suggest parentheses around plus in the operand of the bitwise ampersand. Look at this. This is almost Rust-like in terms of the quality of the error. JTTK was not declared in this scope. So we're just missing it's because we took this out. So maybe we should be doing this one first. Or maybe we should just... Hey, Ahmed. So we've got JT take, then we've got JTTKS, JTTK, and JTTK0, which are all, I believe, variants. So one is a general take routine. Ooh, one is a take on a sparse TKS. So where... So this shows up here. Then it shows up in JT drop as well. And then it shows up in... Right, this is the take. Should we, what do you think? Should we move them all over? I guess that's the thing, is this is like it's a local helper function. So what happens if we just copy and paste it temporarily twice? Why does... Need to add back. TT K0. That's a really bad function name. Behead. That's really bad. I'm starting to think that we should actually just rename this file. Instead of trying to move it one by one. Or just copy and paste the whole thing. Yeah, what happens if you do that? This was take. So what if we do this now? 400 lines. $71. So just parentheses around assignment. Damn, that's so bad. What are they asking? Suggest parentheses around assignment used as truth value. Did I not hit the save button? Oh, I'm not on line 71. I'm on line 73. Yeah, I assumed Bob says behead is monadic. I assume that's the case, but like it's a very violent name, and I don't like it at all. And it's commonly called tail by most programming languages. If we look at Haskell, and we look at a list of 1 to 10, and we go tail, it just drops the first element. And I think calling it behead is, yeah, really bad. It's a really bad decision, especially as it refers to decapitating an individual. I mean, curtail's fine. That has no violent meaning. But we shall definitely be renaming behead, because it seems unnecessary. Yeah, I mean, yeah, there's a lot of better names out there without the violent meaning. All right, 76. We already ran into this error once. And the solution was reinterpret cast AF. Now we're on to line 99. So I guess, yeah, with these longer functions, it's going to take a little bit of time just to get it to compile. So once again, it's just parentheses around assignment. On to line 198. That's a pretty big jump. I think this is what we had before. Reinterpret cast. And we've seen this one before. Asking for parentheses. And this is just a reinterpret cast 299. AF. Um, 412, we're almost done. And 430, I should have, at this point, just copy this, seeing as we're doing it so much. Hey, look at that. So I don't really want to put "and" in the title. What do we call this? Take drop? Take and drop? Take and drop? I don't really like take. I don't like the and. Take drop. What do folks think? What do folks think? I will leave it like this until I get a better suggestion, or if I get a better suggestion. And let's go and remove jsource verbs vt.c. And then let's go to the CMake file, get rid of vt.c, and rename this to, just call it take. Take.cpp. It's take and drop though. I don't know. Well, actually, maybe we should. Well, we'll see if we can split it up eventually and have like a helper file or something, or no, you can't use take exclamation mark. Some languages you can. So yeah, don't save because we deleted it. And let's see, does this build? Look at that. And do our tests run? Yeah, let's call it Drake. I think I saw a fail actually. And why is this hanging? We don't have any tests that take longer than... What part of take as a drop in it? Oh man. Why did we get so many failures? Was it because of the reinterpret casting? My guess is that the drop functionality just is like reversing some argument values and then calling take. Well, this is very sad. Failed, failed, failed. So let's drop down into console, ut, gsp. So sure enough, three, 4. What is x in this case? Do we have x? Oh, we do have x. Look at that. 3, 4, take x. And this does not equal 3, 4, take s. S check I index. Yeah. Bob and Jake are sort of, you said the same thing, two different ways, that a negative take is the same as a drop, and a drop is the same as, yeah, the args. sort of reversed. System error. Let's check index. Ooh, what is S? Oh, is S sparse? Because although we added back the sparse thing, didn't we? Yeah, we added this back. So sad. Let's do this. Let's debug this. All right, let's try that again. Not tally. All right, so well, actually, we need to so yeah, let's take these off again and just run our, what was it? It was GSP, George St. Pierre. So this fails. Now we turn the breakpoint on, and now we go 3, 4, take S, and boom, we're off to the races. So let's, of course, view full screen. Do you think this steps in? So rank is 1. ACR is 1. Oh, Bob mentioned this is sparse display. Numbers to the left of the pipe are indices. Numbers to the right are values. Interesting. So this is an issue with the sparse array that we're having. Right, and it's going to be omega that, because omega here, or W, is S, so that's the sparse thing. So this was checking if our argument on the left, aka the dimensions of what we were taking, if that was sparse, then it was going to make it dense. But in this case, we just have a rank 1 non-sparse array of integers. So how do I get to see more of my locals here? So yeah, now it's saying the rank of omega is 3. Canonicalize x. All right, now we're in JTTK. Oh, I just want to go through and fix the initialization declaration split here, but I will. So T here is the type of omega, and so it's saying if the type is not sparse, go into GT, or actually does not equal 0. So we do expect to come into JTTKS, which is correct. So far so good. So GA sparse is the equivalent of our make array for sparse. What is MCISH? I have a feeling this live stream is just going to be debugging take. Initial port and debugging of take. Copy shapes. Oh yeah, MC stands for memcopy. And SH stands for shape. I do not know what the I stands for. Maybe it stands for memcopy integer shape. I wonder if, what is the operator precedence? I assume we didn't mess that up. C++ operator precedence. Actually, wait a second. Assignment has lower precedence than our comparison operators. What does that mean? That means when previously we had this, the compiler recommendation was actually incorrect. And we should have been parenthesizing the equality comparison, or the not equal comparison. Whoops. So today I learned. I mean, you'd think I should know the precedence of assignment and equality, but I don't ever write code like this. So if you don't write code like this, how are you supposed to know? So I know that there was a couple others, but let's just see if that fixes a couple of the issues. So let's stop that and build again. I'm confused. So now I have parentheses around this expression, but it still wants another set of parentheses. And I assume it's going to say the same thing about the C line. Everything still failed, including this last fifth test. So let's do something here. First, let's what? Oh, right. GC is my shortcut for git commit, not git checkout. And merge main. I've had troubles with what I'm about to do in the past. I'm using a branch that was just committed. But let us attempt to do that. So git add. See you, Jake. We'll probably back. We'll still be on for at least 5 or 10 minutes when you get back. Is it gonna know that we just yeah, that's actually what I'm hoping is gonna happen. Might not happen. Oh yeah, so they are able to tell that we just renamed it. Initial port of take and drop. One commit ahead, 2 behind. Pull origin main. Is this going to work? Yeah, so this is what I want to be able to see. I want to be able to see where we change the parentheses. So port, take, and drop. Alrighty. So what is, maybe we can just, is every single one of these in a do loop? So there's actually only 3 of them. So let's just go see. So line 101. And we're just hoping that this is going to fix it, obviously. So what do we have here? A ternary operator with a colon. So ostensibly the compiler is going to whine about this, which it does indeed. We go and add that. The compiler's now happy. And GSP passed, so that was the issue. All right, fantastic. So actually, let's take a moment. Actually, we can just do it in this branch because this is the only thing we're going to be working on. So LiveStream lessons. So what have we learned so far? Today is the 18th of February. It is LiveStream number 8. So one thing we learned from Bob was that X, Y, Z pipe value is the sparse array view. We learned has lower precedence than equality in C++. Help me out if there's, we looked at a bunch of links. Were any of them? Oh yeah, IRS equals integral / integrated rank support optimizations for certain verbs. See this paper, which I will read later. Oh yeah, we can highlight this. Discovered try J site set up by Nathan. All right, let's go back. So this is working now. Git status. JSource verbs. Git commit. Operator precedence fixes. Bob mentions could be more than 3 indices to the left depending on the sparse matrix. Great point. You get to decide which indices you would like to be sparse in J. Interesting. That is pretty powerful. I know nothing about implementations other than, the naive sort of coordinate. You specify the coordinates so that you can not have to store everything that's sort of a null value. But I wonder how many sparse array implementations give you that kind of granular control. It's pretty neat. And yeah, I am leading towards keeping the sparse types for the purposes of learning. So we should now, if we go back to this, for some reason, these two are still running. Let's refresh this. So yeah, this failed, this should fail, but this should pass. And we can now go back to take drop. So let's take a look at do, and let's just see if we can get rid of this. How complicated is do? Define do. N with something. So this is just a for loop, right? Who wants to guess how many times this macro gets called? I'm gonna say 500 plus. $769. Damn. So this is literally just a for loop from I equals 0 to less than n. All right. Well, that is gonna be easy. So where's the first one? Because yeah, those were single line. So it declares int I. So it declares it to be int 64t. Where r minus m is the first thing, and then we're left with that. So if we do this, we delete this. Oh yeah, clang format document. Interesting. So what is this doing? This is checking whether they're not equal. So does B get used? It does not. And I assume that B is a Boolean. Of course, it doesn't. JType. It's a car. Really? That does get used again down here. But once again, this is used as a Boolean. So we're going to call you a Boolean. So really what this is doing is it's checking in a single line if this does not equal this. Break, and then set bool equal to true. Looks like an algorithm to me. But for now, yeah, this is like, I wonder actually, can we, so we have two ranges. Are we getting ahead of ourselves? I say we, I don't think we're getting ahead of ourselves. I think we should make it an algorithm. Conflicting declaration, right? Clearly a rotate. It's not a rotate. Wouldn't that be awesome if the first algorithm we found was a rotate? It's not a rotate though. It is a mismatch. It is indeed a stood mismatch because we're indexing into two different ranges and we're actually using the default binary operation, not equal to, and yeah, let's actually see if we can do that. Bob is asking, you have b equals 0 and then later, so can you have mixed types? So there is implicit conversion rules, aka otherwise known as coercion. So even though the only two representable types for this are false and true, if you pass it an integer value, there are rules for implicitly converting. So anything that's not a 0 converts to true, and then anything that's a 0 converts to false. But yes, that's a good point, is that we should be doing this. But we're about to rewrite this whole thing anyways with the following. So first of all, let's include algorithm. And we're going to go bool b equals stood mismatch of stood begin of u plus m stood begin of u plus r stood begin of s plus m, and all we're doing is, except this is going to give us back a stood pair. Wah, wah. So if we use an immediately invoked lambda, auto it equals this, return it first does not equal this. And technically we can use cbegin. And then every other time B gets used, I believe is just a reference. So what do folks think? Right, I can't use a trailing return type on a lambda without specifying the parentheses list. cbegin. Is it not? It's in the iterator header. No matching function call for I star ampersand. Is it the cbegins, or is it just the fact that I don't know what U is? Oh, I think actually, so let's go take a look. What do you mean there's no definition for U? U is an int64 star? Oh no. Which means you're able to do pointer arithmetic on it, but I'm not sure if begin actually works on. So is there a way to get this to work? I've never tried to do anything like this. Just to begin on an int star. Yeah, that makes sense. Robert said I finally built the docs, took most of the stream. Sorry about that. Bob says U and V are stand-ins for left and right verbs when using conjunctions, same way that X and Y are used for the left and right arguments of verbs. Nouns used with conjunctions could show up as M and N. That's good to know. That is good to know. Is there a way to like jerry rig this to get it to work? You think I could just use the pointers? Worth a shot. Oh, right. The pair itself is not... the pair returned itself is not a pointer. Interesting. Interesting. Is this too much noise to tech? Well, so first of all, let's actually see. Did this work? Look at that. Who said that? Azal. I don't know why I was... Yeah, I guess I'm trying to think too generically. But so the question... That's amazing. So first algorithm use. The question is, do we prefer... this? And the answer is yes, we do prefer this. I sort of like the auto better. What we really want is to find what the name of B should be. I can't stand when VS Code does that. So let's double check to see I did not build. Let's check to see that this. Wow, this is awesome. Look at, you see, oh, goodness gracious. The difference between, let's take a look. Git diff, jsource, verbs. I mean, how can you say that this code is better than, technically, it's less lines of code. We have 3 lines of code versus a single line of code. Our result is constified. It's not. We know it's not going to be modified later. It's not using a macro, which I guess a J developer would say, well, I know that do is less noisy than a for loop, but here we don't even have a for loop. We have an algorithm that says exactly what this code is doing. And it's also short-circuiting. Like, this is not less efficient than this code. It's beautiful. And it makes me so happy. So, git add verbs. Replace do with mismatch. Our first C++ algorithm. And let's push that. And I said I would end in 2 hours, which is in 4 minutes, but now I'm psyched and I want to go do the other 2 algorithms. And I'm pretty sure this is identical. So this is setting another variable, which is going to be a Boolean. And this time, instead of going from 0 to r minus m, we're going from 0 to m. So we can straight up copy and paste this, get rid of the plus m here, add the plus m here, and then add s here. And then this is going to be this. And we need to go get rid of c. Oh, this is great. I jumped the gun. Do we reassign to C? Line 100. We do reassign to C. So where does C get used? C get used right here. So yeah, the question is what the heck does this mean? And so I don't think that there's any reason why we can't CCC, and if we highlight just a single C, yeah. So we're in TTKS. We're in TKS, which is take sparse. So yeah, maybe we should rename. Well, let's just for now. Let's just put a comment. Take sparse. And so what did Bob say? What did you say earlier? So U and V are stand-ins for left and right verbs when using conjunctions, which I believe is just another word for an operator. I think. But so you can just treat them as your arguments. What is M? Where does M come from? M is the number of atoms. So we're looking for the first two values that don't equal, or to see if there's two values that don't equal So yeah, AV gets you your values, N gets you your number of atoms. And we have A and we have Y. A comes from our input, And y, where do we set up y? Y is, I see. Bob says, an operator with left and right, an operator with only right is an adverb if your definition of an operator is right. An operator with left and right, an operator with only a right argument is an adverb if I have your definition of operator right. Well, let's just go look up. Let's just go clarify. Let's make sure we get this right. JSoftware. JSoftware. Unlike verbs, adverbs and conjunctions have a fixed valence. An adverb is monadic, and a conjunction is dyadic. Interesting. Conjunctions and adverbs apply to noun or verb arguments. A conjunction may produce as many as 4 distinct classes of results. For example, U ampersand V produces a composition of verbs U and V, and hat ampersand 2 produces the square by bonding the power function, aka partially applying the power function with the right argument 2, and 2 ampersand hat produces the 2 to the power. The conjunction ampersand may therefore be referred to by different names for different cases, or it may be referred to by the single term and or with, which roughly covers all cases. So yeah, this is an extension of the idea of an adverb, which is what dictionary APL calls it, and then APL2 calls them operators. So yeah. Thank you for the clarification, Bob. That's very useful. So I believe what this code is doing is y is getting the shape of omega, and a is going to be your literal array that you're using to take or drop values. And so it's checking to see that I believe that the shape and so actually interesting too. B gets used here. So we can actually use a C++17 feature. Although I'm not sure. I think I'm compiling with C++17 right now. And does that work? Oh, that's right, because this is not an extension, so actually we can't do it for here. But we can do it for here. What did you miss, Jake? Well, we managed to convert 2 of our do macros to first for loops and then to algorithms. And currently I'm trying to discern what B and C actually mean. And what is M again? M is the number of atoms. So maybe let's Except actually, what is A1? So yeah. A1 is oh yeah, we should start using our what is SPA? A is one of AEIX. Result is a pointer for that component. Line 49. So sparse axes, sparse element, index, matrix are value cells. Looks like this can be const. So I'm not about to refactor SPA. But really, this is all temporary. Auto MQ technically this is a return 0, which could break some stuff. We'll delete it for now. RZ is for returning 0. Q is also an array. What's the easiest way to do this? So actually we can collapse this all down. So we don't even need Q anymore. Yeah, so it thinks it's an initializer list, which is unfortunate. I mean, we could do, I'm actually not sure which is better, an anonymous struct. I guess you can't even do that, so yeah, you just need to do a std pair. Cannot decompose lambda closure type. Why not? Oh, right. Assignment of read-only reference queue. So I can't have the const on here? So is this going to work? I deleted that return 0, the RZ, which potentially could break something, although really what it's testing is man, why isn't Clang format working all of a sudden? I'll have to fix that. Thanks for tuning in, Bob. We will see you next time. We're probably going to end pretty quickly here, too. Yes, I also love I plus LE. I've gotten my coworkers all hooked on it. So I guess it's fine here. B. So M is the number of, and JT pointer to array values is what these, yeah. Pointer to array values. So yeah, this is just omega. So when I say omega, I mean W, because in 8PL, A is alpha and W is omega for the symbols. And so they've adopted the A and the W are basically shorthand for alpha and omega, which they stole from APL. So this is a pointer to the values in the array of omega, which is where we're going to be doing our take and drop on. Then it does this SPA, which we saw was value fields of sparse array types. So, okay, so it's just some macro that's doing some stuff that's a tiny bit hard to understand, but it's basically just getting us the pointer to our values. And then p-axis does what? Permuted axes per sparse axis specification A. Okay. Permuted axes. So I think this is all just a bunch of hubbubaloo to get the number of atoms I don't know for sure. Yeah, those are classic. Anytime I can use I plus LE, I use it. I mean, sometimes I write a function, sometimes I use a conditional operator. But anything that I can write more declaratively, I basically do. All right, we're gonna resume coming back to do rename B when we figure out what it is doing. I sort of have a, I don't think this is right, but a part of me wants to say that like it's comparing the shapes, the shape of your array with the literal arguments on the left-hand side. And if it's saying like drop everything, then you're just ending up with like an empty thing. Otherwise, because it's checking only after. But that could be totally wrong. Rank. Yeah, because rank is the length of your shape, right? So it's only checking for a mismatch in the elements of your shape from M to R. Anyways, we'll come back to it. The last thing I want to do is just get rid of the last two do loops here. So let's zoom in a tiny bit. So here we're checking so yeah, actually first let's just translate it to a for loop. So for in64 equals m, or actually 0, I less than m plus plus I. And first it's doing this, then it's doing the following. If this is true, CC equals true, and break. Oh yeah, you're right. The other loop does. So how does do work then? I mean, it text replaces with I, so I guess it just shadows, which, how does that even work actually? It's a good point though. Let's in fact, I should have committed my code before I did this. So actually, let's just keep it with I and just see what happens, because that's what the macro is doing. So I mean, this is completely redundant. The only time this actually matters is on the very last one, or if this ever fails to and really this is actually no, it does matter because it's getting immediately used right here. So let's actually do this. So I think T is just, actually I don't know what T is. So this is once again is this a stood mismatch? It is. Oh yeah, and we lost what it was due until M. So we forgot the M here. So I believe this is the equivalent of bool cc equals stood mismatch of, oh, except there's actually 3 ranges we need here. Oh, what a sad story. What a sad story. We have U, we have IV, and we have S. And this is where the standard algorithms sort of fall apart, because we can deal with 1 range, we can deal with 2 ranges, and we cannot deal with 3 ranges trivially. Without like some sort of trickery. So for now, let's just leave this like this, and we can revisit in the future. There is in C++20 actually. So yeah, that's what we should do, is come back here and use ranges. Actually, there's not. There's going to be a zip in C++23. Yeah, and we actually should implement a 3 range mismatch. Except in that case, we would not call it mismatch. We would call it zip find 3. Or maybe we would create a variadic zip find. So this is stood mismatch 3 or stood zip find 3. Yeah. A variadic version. So maybe we can do that next time. Can you make a I think you can make a variadic version that takes an unlimited number of ranges. Yep, I think you can do it. But we'll come back to that, and I think we're gonna have the same issue here. S. So yeah, we'll do this next time. To do use algorithm created above. So let's see. Did I break stuff? It could get hairy. I have faith. Or we could also, I think that's too much work. Look at bringing something in like boost fancy iterators. But yeah, I think that's more effort than it's worth. So yeah, still a ton of work to do here, but we've made some decent progress. Some immediately invoked lambdas. I got to figure out why my Clang format broke, but I'll I'll do that next time. So yeah, let's add JSource verbs. Get status, get commit, further refactoring, I plus LE. Yeah, this is building right now. Should we push these? Yeah, we'll call this part 1. We'll push this. Part 1. And let's go back to lessons. What else did we learn? So we didn't really learn anything, but we used our first C++ standard algorithm. This was std mismatch. Oh yeah, we should also Robert says, when client format does some odd things, I add parentheses and it does better. Jake says, boost is the bane of my existence at the moment. The length of the file path can break the build. That's unfortunate. What we want to do is refactoring. So what do we do? So yeah, we definitely increase the decal init split. How many times did we do that? I mean, it's going to be one of the most used. So technically A1 and Q, B and C, that's 4. And then M. So we'll round up, we'll say 5. We did 5 of these. And use const. How many consts do we count? 1, 2, 3. 3 consts. I don't know if we have a rule for explicit cast, no text. Yeah, technically we got rid of a couple of macros. And I guess we can add to here, do we replace with a for loop, int I equals 0, ms I less than m plus plus I, or std algorithm. All right, Joel, thanks for tuning in. We'll see you next time. We're just wrapping up here anyways. And yeah, did we have any other live stream lessons? I don't think so. Why are we transferring to C++20? I mean, technically we are transferring to C++17 right now. I have not upgraded my compiler for this project to, a compiler that supports C++20. But, I mean, there's some nice things in C++20 that, like, why not? Live at Edge. And I think I think that's going to be it. So git status, git add learning. Update learning docs. And yeah, maybe we'll do another live stream in a couple days because this was fun. We're making progress, and yeah, this has been good. We've only done a little bit. I mean, it's not a drastic number of lines of code changed, but I mean, getting to use std mismatch was pretty awesome. Cleaned up some messy code, and yeah, baby steps. I mean, if the compiler doesn't have support for a C++20 feature, then we're not going to be using that C++20 feature. But like, I think most compilers have pretty good support for concepts now, so that'd be something to slowly work in. Yeah. So waiting for this to pass. While we do that, Flax is a deep learning, library based on JAX. Yeah, I'll look into that. There's some nice links here. And can close this, close this, close this. And we can close this. All right, on the last test. All right, everyone, this is going to pass. Cross your fingers. Thanks for tuning in. I will post the live stream number 9 link either tonight or tomorrow, and maybe this Saturday we might do a live stream, just continuing part 2 of porting take and drop, which have turned out to be definitely more involved than the first few that we've done, but yeah, this has been awesome. So thanks for all your help and the conversation. I look forward to seeing a few of you in the next live stream. And if you're watching this online, I hope you're having a good day. And we will see folks in the next live stream. Adios.